Hey guys, welcome back. This is Mrs. Raro, and in this video, I will show you more examples on how to factor. So in this example, I will show you how to factor the GCF if you see expressions that looks like this or that looks like this. All right. So whether it's a monomial or binomial, GCF is still the greatest common factor between any terms. So in example A, we have 5 times the quantity of x plus 2 plus 3x times the quantity of x plus 2. We must recognize the following, that x plus 2 is common between both terms. In the first term, this is being multiplied by 5, and in the second term, this is being multiplied by 3x. In this case, the GCF here is x plus 2. So if we factor out x plus 2, then what we have left is the following. In the beginning, 5 was being multiplied by x plus 2. So x plus 2 must be multiplied by 5 to get this first term back. In the second term, 3x was being multiplied by x plus 2. So what we have left here is this positive 3x. So this is the factored form once I figure out what the GCF is. All right, let's try a different example. In the first term, we have negative 2b times the quantity of b squared plus 1. In the second term, we have just a plus and another quantity of b squared plus 1. Notice the following, that you have b squared plus 1 from both terms. This is your GCF. The greatest common factor is b squared plus 1. Now, if I write this in factored form, that means my GCF will go first, and I have to figure out what's left. Well, in the first term, negative 2b was being multiplied by b squared plus 1. So if I have a b squared plus 1 that I'm factoring out, then what's left here is a negative 2b. And in the second term, while we are inclined to say, well, there's nothing here, there is something there before the b squared plus 1. That is an imaginary 1. Okay, so again, what's left from factoring out b squared plus 1 is this positive 1. So this is its final factored form. Now we need to identify when to factor by GCF, because we can use this method in the method of factor by grouping. In this method, it groups 2 or more terms together, and then we can factor out the GCF from each term. In all of these examples, you do not see a common factor. You do not see the greatest common factor, just like you see in this example A and just like you see in this example B. However, we can undo this equation or expression so that you can see the GCF in both of these groups. So the first step is for you to group 2 or more terms. Likely, we're going to group together 2 terms. We're going to group together our first term, and we're going to group together our second term, including this plus sign. So focus on the first term and focus on the GCF of the first term. So remember, we're undoing it so that it is in factored form. So the GCF of 6h to the 4th power minus 4h to the 3rd power is 2h to the 3rd power. If we factor out the GCF, which is 2h to the 3rd power, what I have left is 3h as my first term, and then minus 2 as my second term, because when I multiply 2h cubed times 3h, you should get 6h to the 4th power, and when you multiply 2h to the 3rd power minus 2, you should get negative 4h to the 3rd power. The second step is to do the same thing with the second group. Find the GCF of 12h minus 8. The GCF of 12h minus 8 is positive 4. So I'm going to factor out the GCF, which is positive 4, and figure out what's left. If I factor out 4 from 12h, I should get 3h, because 4 times 3h is 12h. If I factor out 4 from negative 8, I should get minus 2, because 4 times negative 2 is negative 8. All right. Now that it's in this format, we can kind of see what we saw in examples A and B, where we have another set of GCF from both of these terms or groups. So another common GCF or another common factor here is 3h minus 2 from both groups. So if I factor out the 3h minus 2, which is common in both terms, what I have left from the first term is the 2h cubed, and what I have left from the second term is a positive 4. This could be my final answer. Furthermore, you can still factor this out because you can still apply the GCF here would be 2. So then this would be 2 times h cubed plus 2, and then multiplied by this 3h minus 2. So this is the final answer, if need be. However, this is okay and acceptable for now, just so you can practice factor by grouping. Okay, let's take a look at this expression. We're going to practice by grouping together my first two terms, and then I'm going to group together my last two terms. The first step is to factor out the GCF from my first two terms. The GCF here is 5y cubed. If I factor out 5y cubed, what I have left is a y, because 5y cubed times y is 5y to the fourth power, and then minus 3 because 5y cubed times negative 3 equals negative 15y cubed. Next, I'm going to take the GCF of my green terms, so in this second group. So y squared minus 3y, the GCF there is y. So I'm going to factor out a positive y and figure out what's left. And what's left here is y and then minus 3. And as you can see here, it's in that same format we were talking about earlier, where now I can identify a second set of GCF, which is a y minus 3 from both these terms. Seeing that we have y minus 3 as my GCF, then what's left from the first term is a 5y cubed, and what's left from the second term is this plus y. Okay. I can further factor this out because I have another set of GCF here, which is y, like I said earlier, and now this becomes y times 5y squared plus 1. So altogether, my final answer is y times 5y squared plus 1, and then times the y minus 3. So these are my final factors. Okay? All right, why don't you pause this video to see if you could do the last one by yourself. Okay, so if the steps were done correctly, you probably group the first terms and then group the second terms. The first term's GCF is a 4r. If I factor out a 4r, what I have left is an r squared plus a 6. Okay. Then the next one, the GCF here, is just 1, because the common term between these two, even if you say there is no common term, the common term between any two numbers is always 1. All right, so 1 goes on the outside, and then in the inside is r squared plus 6. And same thing goes here. We have my second set of GCF, which is r squared plus 6. If I factor that out, from the first term, what I have left is 4r, and from the second term, what I have left is plus 1. And at this point, this is your final answer, because neither the blue group or this second group have another common factor. All right, and that is it. That is factor by grouping. Thank you for watching.